Okay. Assalamualaikum and good morning, everyone.
Waalaikumsalam Doktor.
Hello, good morning. Assalamualaikum.
Morning. Yay.
Hmm.
Another day of boring class. Okay, so yesterday we have learned about bot plot. So basically, bot plot uh, we convert the trans function into magnitude and angle, and then we plot the magnitude in decibel, and then the angle also known as the phase plot. Okay, so we plot the magnitude and angle separately. So one plot for magnitude and another plot for phase angle. And the unique things about bot plot is that the x-axis, the graph has logarithmic scaling. Okay, so you can plot the magnitude against frequency with for a long range of frequency. So yesterday you have seen that it can plot for frequency from 0 until maybe 1000 and more than that. So for today we will go into another type of plot uh, known as Nyquist plot. Okay, so Nyquist plot basically is a type of plot that shows the frequency and magnitude in the same plot. So compared to bot plot, you have to plot two types of plot, magnitude and angle. Sorry, okay. So it's angle and magnitude in one plot for Nyquist. So for Nyquist, you have one only one plot, but represent both angle and magnitude. But the different things in Nyquist is that you cannot represent them in frequency, but for bot plot you can see the frequency changes as you change the magnitude and angle. Okay, so a Nyquist plot is polar plot of impulse response for linear system, and the same thing as bot plot. The procedure for plotting Nyquist plot. What you need to do first is x equals j pole 0. Okay, so example of plot. So see example, it will be the shape will be in circle like whirlpool. Okay, it will keep it will reach the center point, the origin point here 0 0. So this is one part of the Nyquist plot. Okay, so it's actually will circle around. Okay, so in Nyquist plot we also have to determine the gain margin and phase margin, but there is no formula to determine gain margin and phase margin, unfortunately, for Nyquist plot. But the only things that we need to know about looking at Nyquist plot and to determine the stability is that we need to look at this point -1 here. If your Nyquist plot is less than -1 at real axis here, if you look at this blue line here, this thick blue line, this plot is less than -1, meaning that your system is stable. If let's say your Nyquist plot intersect more than -1, then your system is unstable. Okay, so this is what I said just now. So if your system is less than -1, if it intersect at -1, then it is critically stable. And if it's more than -1, then the system is unstable. So that's the only way to determine stability using Nyquist plot. Okay, so we look at an example. So, okay, draw the Nyquist plot, using MATLAB. So ignore the MATLAB part. Okay, so here the transfer function is given like this. So if you can write this in fraction, so s square minus plus 6s plus 3. Okay, so the first step that you need to do is, if you look at your quiz, I already list down the steps. So the first step you need to do is to convert S equals J omega. Okay, so this will become alah apa ni? Apa-apalah. Okay, yang penting you need to convert S equals J omega. Okay, after that, okay, this is the conversion of S equals J omega. So if you have S square, then it becomes J omega squared. So you need to know that J is equals square root minus 1, okay? Square root minus 1. So if J square becomes -1 lah, okay? Previous year, they confused what is J squared. So J squared is basically -1, okay? And after you substitute S equals J square, so the same thing as board plot, you need to determine the magnitude and angle for each of the pole and zero. So this is the first pole, the highlighted, the first block highlighted in red.
Betul.
Yeah.
Yang tu table tu memang disediakan ke?
Tak, table ni kena buat sendirilah.
Oh.
Table ni selalunya dia akan bagi the value of omega, okay? Macam soalan yang example ni, omega tak diberikan. Tapi kalau tengok dalam quiz, I give you 7 value of omega. So buat table, bila buat table, kiralah omega yang pertama kosong, then magnitude dia berapa, angle berapa, magnitude for the second pole, magnitude for the zero, and then magnitude and angle for the overall transfer function. So the same thing, magnitude for overall transfer function, you use product. So magnitude, you use product of magnitude of poles, 0, divided by product of magnitude of poles. And then for angle, you use the sum of angle of 0 divided minus the sum of angle of poles. Okay.
Okay.
I think I already put in the quiz steps. Okay.
Okay.
Okay. And then after that, when you found all the value of magnitude and angle, so this is an example. It use more omega, but in your quiz question, you just use the omega given. Okay, so you don't need to do extra omega. Okay, only determine the omega. Only determine the Nyquist plot from the omega given in your quiz or in your test final exam question later if come out. Okay, so after that, you determine the magnitude and angle. then you can plot the magnitude and angle in S-plane. So you need to remember both plot, you plot in logarithmic graph, but for Nyquist plot, you plot in S-plane, okay? In imaginary plane. So here the example, first is when omega is 0. So you get magnitude 16.67, angle 0. So you use S-plane to plot the points. And then the second one is at magnitude 16.38, angle negative 44.6. Okay, so you measure the angle. Agak-agak lah, okay. Tak payah bawa protractor, okay. Agak-agak je angle berapa. And then maybe the angle you need to, the magnitude you need to measure exactly lah, okay. But the angle can roughly agak-agak je. And then after you plot 2 points, you connect the points by a line. So this red line here is your Nyquist plot, not the black line here. Okay. The red line is the Nyquist plot. Okay. So you repeat the process. So this is the third point. Then you connect the points with a line. Okay. So the red line here is the Nyquist. Then you repeat the process for the fourth point and fifth point and so on. Okay, and then after that, you need to sketch, you need to put the -1 point on the S-plane. So that's why I said you need to agak-agak the angle, but the magnitude you need to measure almost exactly lah. Okay, so that you know that the Nyquist plot either intersect after -1 or before -1. Okay, so here your Nyquist plot intersect after -1. So the system is unstable. Okay. So if you use MATLAB, you can see that the Nyquist plot is actually a circle. Okay, but since you not use MATLAB, so you get only one part of the Nyquist plot. Okay, so that's all for today's class. 15 minit je. So you can try quiz 14. So maybe quiz 13 yesterday, you can try plot on an actual logarithmic graph. Boleh cari dekat Google graph yang exactly macam board plot punya, yang log graph, okay? Tapi Nyquist plot ni boleh je buat dalam A4 paper biasa, kertas kajang biasa, okay? Okay, any question that you want to ask? So next week we will go into final chapter. We will learn about PID controller, and after that habislah kelas, okay? Dah tak ada dah suffering kelas online. Alright, so that's it for today. If you have any question, just text me, and that's all. Assalamualaikum and goodbye.
Okay,
Thank you, Doktor.
Okay,
Assalamualaikum.
bye-bye. Waalaikumsalam.